Owning an affordable electric car has always seemed like a distant dream for many people. After all, high prices have limited these vehicles to a more selective audience. But now, that is about to change. The Tesla Model Q is entering the market with the promise of being the brand's most affordable EV, priced at just $18,897. To put this difference into perspective, the Chevrolet Bolt EV costs $25,600, while the Nissan Leaf starts at $27,800. This means that Tesla has not only entered the compact electric vehicle competition, but has done so with a significantly lower price. The big question is, how did Tesla manage to reduce costs so much without compromising quality? The answer lies in a new manufacturing concept, where every part of the Model Q was designed to be functional, durable, and above all, efficient. Unlike other Tesla models, this one does not include high-end technological features that drive up the price. Instead, it focuses on a robust and reliable setup, tailored to meet the daily needs of any driver. The goal is not to show off, but to deliver an electric car that makes financial sense and fits seamlessly into the routine of those who need a practical and economical means of transportation. Even at this reduced price, the Model Q does not disappoint in terms of range. It can travel between 250 and 300 miles on a single charge, an impressive number for a car in this segment. This puts the Model Q ahead of many competitors that cost significantly more but offer less. For those who use their car daily and want to break free from gasoline dependency, this range means fewer charging concerns, making the transition to an EV even more natural and convenient. Additionally, Tesla has nailed the charging time. While some EVs still struggle with long charging sessions, the Model Q can reach 80% charge in just 15 to 20 minutes. This completely changes the user experience, making recharging almost as fast as refueling a gas-powered car. Even better, the vehicle is compatible with Tesla's supercharger network, which continues to expand, making life easier for EV drivers. Another standout feature of the Model Q is its cost-benefit ratio. Normally, choosing a cheaper car means sacrificing important features. However, in this case, Tesla has managed to maintain the essence of its more expensive models, ensuring a compelling balance between price, technology, and performance. The vehicle includes driver assistance systems, a reinforced structure for safety, and an aerodynamic design optimized for energy efficiency, reducing overall power consumption. Tesla's entry into the affordable compact EV segment is also expected to shake up the competition. Traditional automakers, which have been trying for years to carve out a space in the electric vehicle market, will now have to rush to offer something competitive. The Model Q may force companies like GM and Nissan to rethink their pricing and strategies, igniting a new battle in the budget EV market. Ultimately, this could benefit consumers even further, as they will have more affordable options in the coming years. To achieve such an aggressive price without compromising quality, Tesla had to completely rethink its production approach. The Model Q is not just a cheaper car. It is the result of engineering focused on maximum efficiency. The first major change was in the powertrain. While previous models featured more robust and complex configurations, the Model Q adopts a single motor with rear-wheel drive, a decision that drastically reduces manufacturing costs. Without the need for a second motor for all-wheel drive, components like extra transmission shafts and differentials are eliminated, making the car lighter and cheaper to produce. The battery, one of the most expensive components in any electric vehicle, also went through strategic modifications. The Model Q uses 4680 battery cells, a significant evolution that improves energy performance without increasing costs. These cells are 5 times larger than the previous 2170 cells, meaning fewer units are needed to store the same amount of energy. The result? 35% higher energy density, 10 to 15% weight reduction, and a 14% decrease in manufacturing costs. This allows Tesla to maintain the 250 to 300 mile range, but with a cheaper and more efficient battery pack. Another crucial factor in keeping Model Q costs down is material optimization. While some EV models use premium materials to justify high prices, Tesla simplified everything. The chassis and body are built with a combination of high-strength steel and aluminum, reducing the need for additional structural reinforcements. This not only decreases the vehicle's weight, but also speeds up production since fewer parts mean fewer assembly steps. But Tesla went even further. To cut costs even more, the company is exploring the possibility of recycling used batteries and reusing materials from old battery cells. This process could reduce production costs by up to 30%, making the Model Q even more affordable. Studies show that recycling lithium, nickel, and cobalt from old batteries can drastically reduce the need for mining, which directly impacts costs and improves sustainability. As a result, Tesla can offer a cheaper car without sacrificing quality, while also reinforcing its reputation as an environmentally responsible company. The vehicle assembly process was also redesigned to be more efficient. Tesla has implemented a highly automated manufacturing system, reducing the need for human labor in critical production stages. This not only speeds up manufacturing, but also ensures greater precision in the assembly process. Furthermore, techniques like gigacasting, which allows large parts of the vehicle's body to be manufactured in a single step, eliminate the need for hundreds of individual components, cutting transportation, storage, and assembly costs. Another smart cost-cutting strategy was simplifying the internal components. The Model Q avoids premium materials and focuses on a more functional design. For example, the seats do not have complex electric adjustments, opting for manual mechanisms that reduce costs without compromising comfort. The dashboard has also been simplified, keeping only the essentials for a smooth driving experience. This approach not only lowers the final price, but also reinforces the idea of a practical and straightforward vehicle, ideal for everyday use. The decision to adopt a simplified powertrain and a more compact battery does not mean that the Model Q will be an underpowered car. On the contrary, thanks to the combination of a lighter motor and an optimized battery, the vehicle maintains excellent performance, offering agile acceleration and efficient handling. This is Tesla's biggest advantage, cutting costs without affecting the essence of driving an electric car. One of Tesla's key strategies for keeping the Model Q affordable lies in its design. Unlike the brand's more sophisticated models, this vehicle follows a minimalist approach, eliminating any unnecessary elements that could drive up costs. The key word here is functionality. Every detail was designed to be practical, durable, and cheap to produce, without compromising the driver's experience. This strategy not only lowers the final price, but also simplifies maintenance, making the car more accessible to a much wider audience. The interior reflects this philosophy, with an intelligent use of cheaper but durable materials. Instead of sophisticated finishes like leather or brushed metals, Tesla opted for recycled plastics and sustainable fabrics, ensuring a lower cost without sacrificing comfort. The dashboard follows the brand's well-known style, but with fewer luxurious details. Everything is reduced to the essentials: a central touchscreen to control the car, a clean design, and minimal physical buttons. This not only simplifies production but also avoids the need for constant design updates, which could increase vehicle costs over time. Another important factor is the seats. In previous models, Tesla incorporated electric adjustment and heating systems, adding complexity and costs. With the Model Q, the solution was simple: manual adjustments. It may seem like a small detail, but this represents a significant cost reduction in manufacturing. Without extra motors in the seats, Tesla reduces the use of electronic components, wiring, and sensors, making production more efficient and preventing potential mechanical issues in the future. This simplification also extends to the lighting system. While other models feature advanced headlights with adaptive functions, the Model Q relies on basic LED lights, which perform well without raising costs. Choosing a simpler system does not mean lower quality, but rather a practical approach that prioritizes efficiency. Additionally, Tesla has managed to cut external part expenses by maintaining a streamlined design, eliminating chrome details and unnecessary surface complexity. The Model Q's exterior follows the same cost-effective logic. The bodywork was designed to be compact and efficient, eliminating costly aerodynamic elements that, while useful, are not essential for a budget-friendly vehicle. Additionally, Tesla simplified the car's structure, reducing the number of parts used in assembly. This means that less material is needed for production, which decreases both the vehicle's weight and manufacturing costs. For the Model Q to achieve this competitive price level without compromising quality and efficiency, Tesla had to completely reinvent its production process. And that's exactly what happened. Instead of following the traditional assembly line model, the company implemented an unboxed manufacturing system, a modular approach that revolutionizes the way cars are built. Unlike the conventional method, where a vehicle is assembled from start to finish on a linear production line, the Model Q will be built in independent modules, which are only combined in the final assembly stage. This change has a massive impact on both costs and production efficiency. With separate modules, Tesla can reduce waste, eliminate rework, and speed up the assembly process. This means that the factory can produce more cars in less time, without needing to increase labor costs or expand its manufacturing facilities. Additionally, this new system allows parts and components to be worked on simultaneously in different sections of the factory, optimizing resource use and minimizing delays. Another essential element in this process is gigacasting, a technology that Tesla already uses in other models, but which becomes even more significant in the Model Q. This technique enables the production of large sections of the car's body as a single metal cast, eliminating hundreds of smaller parts that would otherwise need to be assembled separately. The result? A drastic reduction in the number of components, fewer welding points, and a lighter, stronger structure. In addition to simplifying assembly, this also improves the car's aerodynamics and lowers large-scale production costs. Tesla is also taking an aggressive approach to free up space in its factories and prepare for the Model Q's production. Recently, an inventory reduction of the Model Y was observed, with special offers and discounts to speed up sales. This could indicate that the company is clearing its production lines for the arrival of the new compact EV. This stock clearance strategy before a major launch is nothing new in the auto industry, but in Tesla's case, it reinforces rumors that the Model Q is already in its advanced production stages. The launch plan for this new model was also a hot topic in investor meetings. During a Deutsche Bank event in late 2024, it was revealed that the Model Q is scheduled to hit the market in 2025. This information came from internal Tesla sources and was further supported by Chinese media reports, suggesting that the company is already testing pre-production units. Considering Tesla's history of leaks and rumors, everything indicates that the model is very close to being officially announced. Tesla has always placed autonomous driving at the center of its future strategy, and the Model Q will be no exception. Even as an affordable vehicle, it is set to receive one of the brand's most advanced technologies, full self-driving FSD, Tesla's well-known autonomous driving system. Elon Musk had already spoken about progress in this area, but he recently surprised the industry by revealing that Tesla has begun internal testing of the supervised-free version of FSD. This means that the company is working to enable the car to drive completely by itself, without requiring human intervention. Still, there is one big challenge. Today, even Tesla cars with the most advanced FSD version still require the driver to stay alert and ready to intervene if necessary. This is because, despite continuous advancements, legislation in many countries does not yet allow fully unsupervised autonomous driving. However, Tesla's internal tests may indicate that the company is growing increasingly confident that this scenario is about to change. The Model Q, being a compact and affordable car, may seem like an unexpected choice for autonomous driving technology. But in reality, it makes perfect sense. Tesla wants automation to reach as many people as possible. And what better way than to introduce this technology in a vehicle designed for mass adoption? Moreover, the Model Q could serve as a test platform for a future where autonomous taxis and shared vehicles become mainstream. The unsupervised FSD tests, conducted internally, are likely taking place in controlled environments, such as closed tracks or even Tesla's own facilities. Musk has already suggested that the company wants to expand these tests to real-world traffic conditions as soon as it is permitted. However, for this technology to be adopted on a large scale, there are still regulatory and technical challenges that need to be overcome. Even if the Model Q does not leave the factory with 100% autonomous driving enabled, it will certainly have hardware ready for future software updates. Tesla has been following this strategy for years, selling cars with sensors and cameras that receive improvements through over-the-air updates over time. This means that even if unsupervised FSD is not available at the launch of the Model Q, the car could receive this functionality in the future as laws and technology evolve. Another important aspect is the relationship between FSD and the affordability of the Model Q. If Tesla can reduce the cost of this technology and include a reliable autonomous driving mode, this car could become an attractive option for transportation services and commercial fleets. Imagine a scenario where the Model Q is used in autonomous taxi fleets or ride-hailing services without a driver. This would open a new market for Tesla and could further accelerate the adoption of electric vehicles worldwide. For an electric car to be truly efficient, it is not enough to have a good battery and an optimized motor. Aerodynamic design and lightweight construction play a fundamental role in range, performance, and even the final cost of the vehicle. In the case of the Tesla Model Q, the company has adopted an approach that seeks to balance efficiency, weight reduction, and functional design, all without compromising the car's durability. The first major differentiator of the Model Q is the materials used in its construction. Tesla chose a combination of high-strength steel and aluminum, reducing the need for heavy structural reinforcements while ensuring that the car is both lightweight and safe. This choice helps decrease the vehicle's total weight, which in turn improves energy efficiency and allows it to achieve a 250 to 300-mile range without requiring an oversized battery. Another major innovation is the application of gigacasting technology, a manufacturing process that enables large sections of the body to be produced in a single cast metal block. This method reduces the number of individual parts that need to be assembled, meaning fewer bolts, fewer welds, and fewer potential wear points. In addition to making the structure more robust, this technique also helps cut costs and speeds up the production process. The aerodynamic design of the Model Q has also been optimized to ensure maximum efficiency. Tesla fine-tuned the body lines to reduce drag and improve airflow around the vehicle. This means the car encounters less resistance while moving, requiring less energy to maintain higher speeds. Small adjustments, such as a slightly sloped hood, flush door handles, and aerodynamic wheel designs, contribute to this superior efficiency. Speaking of wheels, Tesla opted for a smaller, more efficient set on the Model Q. While other Tesla models feature larger wheels, which increase energy consumption, the Model Q will have smaller diameter wheels designed to maximize efficiency and improve range. This might seem like a small detail, but it makes a big difference in daily driving, especially for drivers who want to get the most range out of each charge. Another key factor in weight reduction was the optimization of the battery pack. Thanks to the use of 4,680 battery cells, the Model Q can have a battery pack up to 30% smaller than that of a Model 3 without losing efficiency. This not only contributes to the car's lightweight construction, but also reduces costs and improves weight distribution, ensuring a more balanced and comfortable driving experience. The Model Q structure also includes reinforcements made of carbon fiber reinforced polymers, a lightweight yet strong material that is increasingly used in the automotive industry to replace heavier metals. Although these composites tend to be more expensive, Tesla is exploring ways to manufacture them more affordably, ensuring that the Model Q remains lightweight without significantly increasing production costs. Beyond lightweight construction, Tesla optimized the interior space to ensure maximum usability within the Model Q's compact size. The rear trunk has been designed to offer 350 to 400 liters of capacity, while the front trunk adds another 50 to 60 liters of usable storage space. For a car in this category, this combination of cargo capacity and efficient design makes a huge difference for those who need practicality in their daily lives. In the end, Tesla has found an impressive balance between weight, efficiency, and cost in the Model Q. The result is a car that not only delivers solid range and performance, but also redefines what to expect from an affordable EV. But what does this really mean for the market? With Model Q production approaching, competing automakers will have to react quickly to keep up with this new reality.